So we have talked about atomic number, right? Atomic number. See what it says. Atomic number, right? Atomic number is the number of protons in an atom. Right? Number is the number of protons in an atom. Atoms of different elements contain different number of protons. So they have different numbers. Chemically, the atomic number is a very unique feature, right? Atomic number is a more unique feature for an element, right? එකම atomic number එක තියෙන elements දෙකක් තියෙන විදිහක් නැහැ. There will be only one element which contains a particular type of atomic number, right? කියන්නේ atomic number එක කියන්නේ හරි unique feature එකක් මේ elements වලට, right? එකම atomic number එක තියෙන elements දෙකක් තියෙන විදිහක් නැහැ. එකම atomic number එක තියෙන elements එකයි. හරිද? So how to find out the atomic number is represented by the number of protons of an atom. එතකොට ඕනම එක number because of that their numbers also different. After hydrogen, right? We talk for example, right? Talking about an example is hydrogen, right? If you talk about hydrogen, right? Hydrogen is one proton. सामान्य आप क्या right? So when you talk about hydrogen का एक proton, here now atomic number 1. Okay. So when you talk about other element, for example, talk about helium. Helium के atomic number atom देखा, right? it's what यार number of protons right? यहाँ number two protons, which means atomic number में आगे equals to. So what you have to understand from this is every atom has a particular number of protons in them, and that number of protons indicate the atomic number, right? One atom number of protons are a specified number of protons, and that reflects the atomic number. And the very important part is the atomic number of an atom cannot be changed, right? The atomic number of an atom cannot be changed. So, which means the number of protons of an atom never changes, right? So, atoms have a particular number of protons, they never change because the atomic number is represented by the number of protons. So, protons will never change in an atom. They can have hydrogen, forever it will have only one proton. Can a monomer is one hydrogen, the number of protons will not vary. The atomic number will not vary, right? So, I've given you some space to write examples. I will put some examples. Right? I gave you two examples: hydrogen and helium. Hydrogen one atom, two protons, one proton. So the atomic number is 1. Helium has 2 protons. So the atomic number is 2. Right? Structure of matter tubes ටික ready කරලා තියෙන එක නම් groups වලට දැම්මා. සමහර කට්ටිය ඇවිල්ලා අරගෙන ගියා, සමහර කට්ටිය ඇවිල්ලා අරගෙන ඉන්නේ නැහැ. අරගෙන ඉන්න කට්ටියට මට කරන්න දෙයක් නැහැ. right? 11s now. print කරලා තියෙන්නේ මේ අපේ church කට්ටියට ඇවිල්ලා ගන්න පුළුවන් institute එකක්. right? Be very quick now. right? Let's start. Right? Number of protons in that. The atomic number is a very unique characteristic of an element, right? So highlight it's a very unique characteristic. Unique and unique number. But atomic number is there can be only one atom with a particular atomic number. Okay, unique feature, right? Okay, the next thing. Atomic number of an element is symbolized by Z. Z again තමයි atomic number එක symbolize කරන්නේ. මොකක්ද මේ symbolize කරනවා කියන්නේ? ඒක ඔයා කවුරුහරි atom එකක් දාලා අන්න atom මෙතන වගේ atom එකක් වෙනවා. මෙන්න මෙතන Z කියලා දානකොට this is the atomic number, right? It is this illustrates the atomic number. සාමාන්‍යයෙන් මම කිව්වා in any atom the atomic number will be illustrated or indicated at the base of the atom. So is usually symbolized with Z. සමහරවිට ඔයාලා question atom X has Z equals to 2. That means its atomic number 2. Right? You should know how to understand these are questions. So that's why these things are given. But it's simple, the atomic number 6. Okay? Right, let's start. Number of protons equals number of electrons in a neutral atom. This is not the last day, right? So as I told you, the electrons and the number of protons in a neutral atom is equal. So now just come to this solution. Let's talk about hydrogen. As I told you, the atomic number of hydrogen is 1. So when you read this number as the atomic number 1, you know there will be number protons, there should be 1 that has a positive charge. Okay. So when you read this diagram, hydrogen and the base you have got, that means you know that is the atomic number. Atomic number means the number of protons, that means the proton number in this atom is 1 that has a positive charge. So if we now then you want to look for this thing, right? This part, this thing. Okay, what I have marked with the star part. If there's no positive or a negative side, we discussed a little about these ions, right? If there's no positive or a negative charge, which means this atom has to be a neutral atom. For that, to cancel out that positivity from the one negativity, right? That negativity actually comes from electrons. So then electrons, if you see the electron number, electrons also they should be 1. So altogether, the net charge of this atom will be 0. That means this is a neutral atom. Shall we go for another example? Right? If you talk about let's say carbon, with carbon base we indicate the 6. Okay, once you see base, you know that is the atomic number. If atomic number is 6, proton number you also should be 6. That means you have 6 positive charges. And look for this right corner, there's no charge over there. This corner, there's no charge over there. So then you know this is the neutral atom. So then you have to cancel out all these 6 positive charge, positivity of this 6 protons. Cancel it out, means 6 negative charges charge electrons. So with that you understand, this also has no net charge, which means this atom is a neutral atom, right? So we have studied it already on the last week, right? So you know the number of protons and the number of electrons in a neutral atom is equal. Number of protons and number of protons and the number of electrons in a neutral atom is equal, right? Right? In which chemical reactions, atoms will gain or lose electrons. Last week. Okay, we will discuss it further. Right? So during chemical reactions, an atom may lose, gain, or share electrons. Okay, during a chemical reaction, an atom can lose, gain, or share electrons, but not protons. Right? As I told you, the proton number tells you the atomic number, and it never can be varied. So the number of protons remain the same. But electrons can be lost, gained, or shared, right? Right? So that's a very important point. We highlight that lose, gain, or share electrons. If an atom gains, we have talked about that here, right? Okay, if an atom lose or gain electrons, right? If an atom lose or gain electrons, a net charge remains in the atom. And then they are called ions. So I'll tell you what ions are. So we so far discussed about what neutral atoms are. They have equal number of protons and electrons. So then I'll tell you what will happen to an atom if it loses electrons, and what will happen to an atom if it gains electrons. I'll tell you what will happen to that, right? So then the number of electrons in a charge atom, right, which means an ion. So we call the charged atoms as ions, right? So far in the book, we discussed about neutral atoms, right? In neutral atoms, the number of protons and the number of electrons are equal. Top right corner, right? See here, so we spoke about these neutral atoms. In these neutral atoms, the top right corner is not indicated with anything. Indication right? So that you will understand that this is a neutral atom. So then the proton number and the electron number has to be equal, right? Okay. So if it is a charged atom, if it is a charged atom, charged atoms are of two types, right? Charged atoms are of two types: positively charged atoms and negatively charged atoms, right? Charged atoms are of two types: positively charged atoms and negatively charged atoms. If it's a positively charged atom, the element, the atom will be indicated with a positivity on the right hand top corner. If it is a negatively charged atom, the atom will be indicated with a negativity on the top right hand corner. That's why I said look for this positive, look for this right hand top corner. If it has nothing, the atom is neutral. So then the proton number and the electron number should be equal. If it has a positivity, it's a charged atom. I'll tell you what it has done. The proton number and the electron numbers are not equal in such a type of atom. And if it is a negative atom, if you have a negativity on the top right hand corner, this is again not neutral atom. It has equal numbers of protons and electrons. Simple, right? So what you can do for, look for the top right hand corner. If you have a positivity, it's a charged atom, charged ion, positively charged ion. If you have a negativity on the top right hand corner, it's again a charged atom, a negatively charged atom. So a negative ion. If it has nothing, for neutral atoms, nothing will be there, right? For neutral atoms, nothing will be there. It will be just black. If it is so, it's a neutral atom, which has a equal number of protons and electrons, right? Okay. So then, the next thing, now I have what will happen to neutral atoms to use of electrons and it gains electrons. That what will happen. Okay, right? So atoms, number of electrons in the charged atom, we call it as maybe more less than the usually for neutral atoms we know the protons and the electron numbers are equal. Atom में का neutral ना proton number का electron number का equal. Habai का charge ना proton and electron numbers are not equal, right? So here, if an atom loses positive ions are formed. Okay, I'll tell you what really happens. So then we balance there. What if an atom loses its electrons, right? Atom में का electrons lost over the way. That's what we are going to see. Okay, lost over the way. Right. So far we discussed about neutral atoms. We had equal numbers of protons and electrons. Then we balance about positively charged ions and negatively charged ions. What will happen to an atom when it loses electrons? Right? Okay. I'm talking about I'm talking about oxygen. Okay? Right? Oxygen. It's like this. Oxygen. We talk about oxygen. Atomic number of oxygen is 6. Okay. So here, the atomic number of oxygen is 6. So in this case, we have talked about protons. Let's talk about protons. So atomic number 6 is 6 means proton number also should be 6. Protons should be 6, which are positively charged. So now in this case, this is neutral atom, right? Neutral atom. So electrons also have 6. So then positive 6 and negative 6. If you consider the net charge can overall charge. If you consider the net charge, that is here. It can be other neutral atom. It's a neutral atom. Okay, it's a neutral atom. Fine. Done. And now we are talking here about losing of electrons by this atom. Now I'll tell you that electrons in this atom is arranged in a different way. I'll tell you how they are arranged later when we talk about the electronic configuration. But before that, I'll just write because I need to use it for your explanation, right? So if electrons are like so electrons in this here is like this and actually this is electrons hold on. We are talking about first of all, we are talking about right? I'm sorry. So we'll talk about something else. Right? We'll talk about sodium to show you how electrons are lost. Right? Okay. So here we have sodium. Sodium atomic number is 11. So when you see the atomic number, when you see the atomic number, you know the number of protons. Number of protons, it has to be 11. Those are positively charged. And you look for the right hand top corner. There's nothing. Right hand top corner has nothing, which means there is a neutral atom. So to cancel out this 11, you need to have 11 negative charges, which are electrons. Which are electrons. So when you check for the net charge, right? Net charge here is 0, which means this is a neutral atom. This is a neutral atom, right? Now our problem is, what if it loses one electron, right? What if it loses electrons, right? So let's consider what if it loses electrons. I'm telling you, how many electrons does it have? 11 electrons. I'll mention how the electrons are distributed. They are distributed like this actually. 8 and 1. You don't want to worry about how these electrons are distributed. We just do talk about the distribution of electrons. We call it as electronic configuration, right? So we are going to see what loses electron. So this electron is going to be given out by this electron will be given out. Okay. So if it gives out the electron, okay, still you have school. Nothing will happen with atomic number. Why? Atomic number means number of protons, but it is give up an electron. So when it gives up an electron, nothing will happen with proton number. So proton number remains same. The atomic number also remains the same. So the atomic number here is the same. So protons, that is their level, which is positively charged. And talk about the number of electrons. It has 2 electrons, which is 11 electrons. One that was given out. So then electron, each number of electrons is 10, negative 10 electrons are there. So then if you see for the net charge, right? See for the net charge. See for the net charge, positive 11, negative 10. That will be positive 1. Okay. So now this is now the configuration. Let's talk about configuration. From the configuration, let's say 2, 8, because the one which is on the last element was given out by this atom. Now you can't call it any more a neutral atom because it's not neutral. Right? Positive one, negative one. It's not a neutral atom anymore. So we have to call it a positive atom. Right? Positive atom. Positively charged atom. Positively charged atom. Basically, you use the word atom for this positively charged structures. We call it a positive ion. We call it a positive ion. A positive ion. So these positive ions are all simply cations. Positive ions are all cations. So the next thing, you can't leave like this because can you remember to identify whether it is a charge atom or a neutral atom? We look for the right hand top corner. So if you see this atom right hand top corner, there's nothing, which means it's neutral. That means that positive charges and negative charges has to be equal. Make the right hand top corner value because here the proton number and the electron numbers are not equal. Electron number is so the number of electrons are less. That means this atom has a positive charge. That positive charge has to be indicated. Right? It doesn't matter if you don't mention numerical value because it's 1, you can just indicate positive also. But if it has lost 2 electrons, you have to indicate positive 2 is the charge by the atom, right? So if you see an atom like this, positive become now the atom become that right hand top corner. Keep it in your mind. This type of an atom is not neutral; it's a positively charged atom. How a positively charged atom is made by losing electrons. In a lost electrons made by the atom, take a number of protons electrons right? So keep it in your mind. This is how positive ions are made, or the cations are made, right? Quickly move it down. How the positive ions are made, cations are made. And you should know how these positive ions are formed now, right? Positive ions are there with the And then we will be talking how the negative ions are formed, right? Negative ions right? Okay. This is how they are formed, right? Right. So I'm going to take another element. Chlorine, right? Chlorine. So chlorine can you see? Chlorine's atomic number is 17, right? In protons proton number will be 17, and that is a positive charge. And look for the right hand top corner. There's no positive negative sign, which means this is a neutral atom. So here I positive. So for that you need negative 17s, right? Negative 17. That means how many electrons are there? Electrons. How many electrons? There are 17 electrons. So positive 17 electron cuts off with negative 17 electrons. So the net charge will be 0. So this is a neutral atom. This is a neutral atom, okay? And electrons 17. So we will see these electrons are distributed like this 287. You don't have to worry about how the electrons are distributed. I will teach you how that is written, right? Just remember 2 and 8 is 10, 10 plus 7 is 17. This is what the number of electrons this atom has. So now we are going to talk what if this atom accepts an electron. Okay, what if an atom gives up electrons? Now we are going to talk how it will be if it accepts an electron, right? Electron accept kara. So the thing what you have to understand here is it accepted electron, not a proton. So the proton number of the atom has not changed because nothing happened to the proton number. The proton number remains the same, right? Chlorine proton number proton number still remains as 17. Still remains as 17. Proton number still remains as 17. So the proton number is 17. And as you know, protons are positively charged. What can you say about the electrons? Electrons, it had 17 and it accepted one more electron. That means the electron number here. Electron number 18, negative charge. Negatively charged electrons, the heart of So if you consider for the net charge, you would see protons, electrons are greater than the number of protons. So positive negative there will be one negative charge remaining. So this is not anymore a neutral atom. This is a negatively charged atom. As I told you, negatively charged atom we usually do not call them. So we call it as a negatively charged ion. Negatively charged ion. It's again ion. So we call it as an anion. Anion. Negatively charged ions are called anions. So the thing is, right hand top corner. Then we have electrons here. 2, 8, 8. Extra electron. So the thing is, now you can't just let it be like this because it's not anymore a neutral atom. The proton number and the electron number in this atom are not equal. Electrons, one electron is greater than the number of protons here. So then we have to indicate it is a negatively charged ion. It has accepted extra electron, and then the number of electrons in that atom is greater than the number of protons. So we have to indicate that, right? So simply making what theory when atoms accept electrons, their electron number increases than the number of protons, and they become negatively charged ions, anions. When atoms lose electrons, their electron number goes down than the proton number, so they are more positive. So we call them as positive ions, cations, right? So this is what you have to copy down. How the negative ions are formed. Oh, what will happen to an atom if it loses an electron? If an atom gains electrons, the number of electrons will be greater than the number of protons. So the atom becomes not anymore neutral, it becomes a negatively charged ion or an ion. If an atom loses electrons, atom will have more protons than the number of electrons, right? So that means they will remain with a positive charge. So we call them as positive ions or cations. Quickly note it down. Right. So then here the number of protons in an atom never change due to any reason. Highlight that. That is very important. The number of protons in an atom never change due to any reason. Okay. The position of the element in the periodic table is determined by the number of protons, or the number of is determined by the atomic number, or the number of protons of an atom. Right. That means, as you know, the number of protons and the number of protons and the atomic number, they are similar, right? Proton number and atomic number can be determined. So according to the atomic number, only the periodic table is designed. So the elements are positioned in the periodic table depending on the atomic number. So then hydrogen having the atomic number 1, atomic number equals 1. This guy is the first element in the periodic table. Okay, so how do we arrange them in the periodic table? According to the atomic number. How do we arrange them in the periodic table? According to the atomic number. So this one has the atomic number 1, which has the first place in the periodic table. Right. The next thing, let's talk about calcium, which has the atomic number 20, right? Atomic number, which is 20. That means this one is the 20th element in the periodic table, right? You don't write the whole sentence, but if the atomic number is 1, first element in the periodic table. If the atomic number is 20, the 20th element in the periodic table. Quickly go for this. Here's the space you have to write it on this space. Patagala liyagan. Right. Okay. Quickly write it. Quickly write it. Okay, the next one, we have to talk about the mass number. Okay, so here, when you talk about the mass number, if you can remember the subatomic particles present in an atom, there are 3. Okay, protons, electrons, and the neutrons. Out of all those 3 subatomic particles, if you can remember, the electrons had a negligible mass. So we consider them to not have a mass actually. That means we consider them that they have no capability of donating or contributing a mass to the atom. Can ඒගොල්ලන්ට mass එක හදන්න donate වෙන්න බෑ atom එකේ. So we consider electrons have no mass, negligible mass එකක් තියෙන we consider electrons have no mass. What are the subatomic particles in the atoms with a mass? Atomic subatomic particles with a mass are protons and neutrons. Protons and neutrons වලට විතරයි atom එක mass තියෙන subatomic particles that consider කරන්න පුළුවන්. So they both are inside the nucleus, if you can remember. So the number of protons and the number of neutrons tells us the mass number. Number of protons and the number of neutrons tells us the mass number. Mass of electrons of an atom is negligible. So mass of an atom is determined by the number of protons and number of neutrons. Here you have the equation. Mass number means the number of protons and number of neutrons in the atom. The mass of protons are nearly equal to the mass of protons. Protons are like neutrons are like mass are nearly equal. As you can remember, I told you the neutrons have a very slightly less mass than the protons, but we consider them to have nearly equal masses. Okay, right. So the mass number of an atom is indicated by A. Mass number of an atom is indicated by A. Okay, so then we are going to understand the standard scientific method of indicating the mass number and the atomic number of an atom. Okay, so this is how I have given you a box. In this you have to note it down. Just hold on for a second. I'll just tell you what it is, right? Okay, it's like this. मैं मुझे box से कभी use करने का because I'm going to give you another thing to work out and get me the answers in the same place. So save your space. It's like this. So I'm talking about an element called Sx. Okay, I'm talking about an element called X. At the base, Z. This tells you atomic number. How the atomic number is determined? How the atomic number is determined? By the number of protons. Okay, atomic number means what? Number of protons. Okay, number of protons is the atomic number. So at the base, what is indicated in an atom? Atomic number. It is symbolized with Z. What is the atomic number? The number of protons. Right. Next one. The mass number is indicated over here. A. That is the mass number. Right. A. That is the mass number. Okay. That is the mass number. Mass number means what? Number of P plus number of neutrons. Number of protons plus number of neutrons. That is the mass number. Okay. Hope you can't see it. Hold on. Right. What is the mass number? I would just mention it like this. What is the okay? Hold on. What is symbolized at the top? Mass number. First, I have to write that mass number. How the mass number is found? Protons plus neutrons. Okay, this is how it is done. So, what is basically indicated at the base is Z. Z means the atomic number. Atomic number can be obtained by the number of protons. What is indicated as A on the top? That is a mass number. Mass number could be obtained by the number of protons and by the by summation of the number of protons and neutrons. Right? Quickly go for this. Just mark it. ගොඩක් වෙලා ගන්න එපා පටස් ගාලා මාක් කරන්න. Right. Hope you're done. තාම කවුරු හරි කරන කෙනෙක් ඉන්නවද? තාම කරන කට්ටිය ඉන්නවද ළමයි? Okay. Right. So we are moving for the next part. I need you to do this for me, right? මෙතන මම ඉඩ තියලා තියෙනවනේ ඔයගලන්ට පල්ලෙහා පොඩ්ඩක්. Right, මේ box එකේ දා ගන්න තරම් ඒක හරිනේ. මම මෙතන පල්ලෙහා ඉඩ තියලා තියෙනවා. This is for a sum. Okay, a sum in the sense you need to work this out and tell me the answers. Okay, Right, see here. So I'm going to give this to you like this. I'm going to give you a chlorine atom. Okay, chlorine atom. Chlorine atom is like this. Chlorine. Okay, I'm telling you the base has the number 17 and the top has the number 35. So I want you to tell me atomic number, number of protein, number of protons, number of electrons, then the mass number, then the number of neutrons. I want all of the answers for these questions. Atomic number, number of protons, number of electrons, the mass number, and the number of neutrons. I'll give you just 30 seconds. Quickly go through this and get me the answers for this. Right? How to find out the number of neutrons? So, what is the mass number? That's 35 on top. Right-hand corner, sorry, left-hand corner. How to find out the number of neutrons? Mass number equals protons plus neutrons. Mass number is 35. Proton number is 17 plus neutron number. We know the mass number and the proton number. So when you subtract the proton number from the mass number, you will get the neutron number, that is 18. Right. Ready for the tamat karna kattiya. Shamal ki varda?
Oh, sir.
Right. Okay. Okay, right. So then we have to talk about the electronic configuration. Okay, we have to talk about the electronic configuration. Electronic configuration is the way how the electrons of an atom are distributed. See here, electronic configuration of an atom is the way how the electrons of an atom are filled in respective energy levels of the atom. One which is nearest to the nucleus, from the one which is nearest to the nucleus to the outward direction. Then what matakane? Every atom has main 4 energy levels. K, L, M, Kela. Every atom has main 4 energy levels. So electrons should be filled in those energy levels. If you can remember, any atom has 4 energy levels: K, L, M, N. So that the electrons of each atom should be occupied in these energy levels. Okay. If you can remember, each of these energy level had a maximum number of electrons that could be occupied in them. First energy level ki maximum electrons second energy level maximum number of electrons, you can put 8 electrons in it. Third energy level, to be honest, there can be 18 electrons indicated, but we don't indicate first 20 elements configuration and we only write the electronic configuration of first 20 elements. So when we write the electronic configuration of the whole set of elements in the periodic table only, we will need all the 18 number of electrons in the third energy level. But for our level, to write only 20 configurations of first 20 elements, we don't want to fill this energy level with the total number of 18 electrons. So what do? We only fill maximum of 8 electrons. Then third energy level S orbit, which could be filled with 2 maximum of electrons, and a P orbit, which could be filled with maximum of 6 electrons. Third energy level we only fill the S sub orbit and P sub orbit. Electrons first 20 elements of the configuration and we only fill 8 electrons, not 18. We don't need to put 18 electrons. We only put how many electrons? 8 electrons. And the third energy level, if you can remember, it could be filled with 32 maximum electrons, but we are not going to put 32 electrons. We are only writing first 20 elements configuration. So පළවෙනි elements 20 configuration එක ලියනකොට outer energy level එකට electrons 32ක් දාන්න you will not need නේ. So we will only fill maximum of 2 electrons into that. We will have to fill only maximum 2 electrons into that. එතකොට first 20 elements of the configurations we can complete it, right? So the thing is, when we are writing the electronic configuration, we have to know how much of maximum electrons could be occupied in each energy level. So the first energy level, we have to fill maximum of 2 electrons, and the second energy level, we have to fill maximum of 8 electrons. Though the third energy level could be occupied with maximum of 18, we only have to put 8 electrons to write the first 20 elements configuration. And the fourth energy level, which is the KLMN, can occupy with maximum of 32 electrons, but we will have to put only 2 electrons when we are writing the electronic configuration of first 20 elements. We don't have to put all 32, right? So then this is how the electronic configuration is written. Okay, so when you talk about the atom hydrogen, the first element in the periodic table is hydrogen. First element in the periodic table is hydrogen. If it is the first element, the atomic number has to be 1. Okay, if it is the first element, the atomic number has to be 1. That means protons here should be 1, positively charged. How many electrons? See here the top right hand corner, it's a neutral atom. Number of electrons, that's 1, right? Number of electrons here will be 1. So there will be only 1 electron. So then what do we have to do? In the first energy level, what is the first energy level? That is the K energy level. In K energy level, 1 electron can be inserted in the hydrogen atom. So let's talk about the second element. What is the second element? Number 2 element is helium. Number 2 means the atomic number has to be 2. Atomic number has to be 2. So then protons has to be 2, positively charged. Neutral atom, so then the electron has to be also 2. So in the first energy level, as you can remember, first energy level can be occupied with maximum 2 electrons. So then first energy level, in the K energy level, you can put the direct number 2 because it can be occupied maximum of 2 electrons. Then we go to the next one. Let's go for the next one. Let's go for the third element. Third element, the atomic number 3 is lithium. Okay. Lithium's atomic number is 3. So then proton number should be what? 3. So it's a neutral atom. So then electron number also has to be what? 3. Okay. So if you can see here, in lithium, first energy level can be occupied with maximum of 2 electrons. On them or that 2. And there's one more electron to be put. Yes. Lithium has 3 electrons. The first energy level, K energy level can be occupied with maximum of 2 electrons. You have already done it. The remaining one goes to the next energy level, 1. So altogether 2 and 1. So in lithium, actually 2 energy levels are filled with 3 electrons, right? First energy level is totally filled with 2 electrons, and the second energy level, which can be occupied with 8 electrons, is filled with only 1, right? So this is how the electronic configuration of first 20 elements will be written. So I'll just give it a guide for you to do it like this. Okay, like this. So name of the element, hydrogen. Symbol is capital H. Okay. So atomic number is what? Atomic number is 1. If the atomic number is 1, you know the number of proton is 1, number of electrons also has to be 1. So before that, we will just fill it like this, right? So K energy level, we can maximum put 2 electrons in it. We have to mention it. L maximum you can put 8 electrons. Actually, M can be put with 16, but what do? We only insert 8 electrons. N you can maximally put 32, but we don't have to put 32. We only go with 2 electrons. When we go like this, we can fill out the electronic configuration of all first 20 elements. Okay, right. Okay, so then hold on for a while. So then let's go how it is. Let's see how it is done. Right. Okay. Hydrogen. Symbol capital H. Atomic number 1. That means proton number is also 1. That is equal to the electron number.
So electron number is 1 in the first energy level, 1 electron is filled. Helium, symbol He. Atomic number, that is 2. In the first energy level of K, you can put the 2 electrons. Lithium, Li. Atomic number 3. In the first energy level, you can put 2 electrons. In the second energy level, you can put the remaining 1 electron. Beryllium, that is B, capital simple C, simple E. Atomic number is 4. 4 electrons are there. 2, 2. Boron, capital B. Atomic number is 5. So that means electron number is 5. First energy level can be occupied with maximum 2 electrons. Second energy level, you can put all the 3 remaining electrons to get the 5 electrons, right? So keep like this, keep on doing. Carbon, atomic number is 6. Anjali මාව ඇහෙනවද?
ඔව් සර් දැන්
හරි. Right. කට්ටිය ලිව්වද? ටක් ගාලා ලියමු carbon වලත් right carbon atomic number is 6, number of protons will be 6, that means number of electrons also 6. So 2 4. Okay. The next nitrogen symbol like N, atomic number 7, again number of electrons also 7. So 2 5. Oxygen, capital O, atomic number 8, that means number of protons and number of electrons are 8. 2 6. Fluorine, F, atomic number 9, number of protons are 9, number of electrons also has to be 9. So that's 2 7. Neon, capital N, simple E, atomic number 10. Electronic configuration will be 2 8. Okay, sodium, the 11th element. Okay, atomic number 11, that means proton number 11, electron number will also be 11, that means 2 8 and 1. Magnesium, Mg, 12th element. Electrons, there are 12 electrons, 2 8 and 2. Aluminium, capital A, simple L, 13 atomic number, 2 8 3. Silicon, Si, 14th element, that means you have 14 electrons, 2 8 and 4. Right. ළමයි මෙතෙන්ට ඉවර කට්ටිය කවුද? මෙතෙන්ට නිකන් තාම ලියන කට්ටිය මට පොඩ්ඩක් උස්සන්න. හිමාශි ලිලිවරද? ඉෂාන් ලිලිවරද?
ඔව් සර්
Okay.
ඔව් සර්.
හස්මිතා ලිව්වද?
ඔව් සර්
Okay. Right. එහෙනම් අපි යනවා ඉතුරු ටිකට. So we have done up to silicon, which is the 14th element. 15th is phosphorus. Capital P, 15th. Electron number will be 15, 2, 8, 5. Sulfur, that is the 16th element, 2, 8. Hold on. 2 8 6. Right. Chlorine, Cl, 17th element, 2 8 7. Argon, Ar, 18th element, 2 8 8. Potassium, He, 19th element, 2 8 8 1. Calcium, 20th element, 2 8 8 2. This is how the configuration goes.